Okay, so I'm going to briefly explain what moles are, and this is actually really important. It's going to be one of the first things that you hear about, but also the most important things, because this actually defines everything that we do in chemistry, so it's really important. And the reason as to why is if you think about how small particles are, they're so tiny that it's very difficult for us to quantify them, and it's very difficult for us to count them individually. It's very similar to if I went into the shop to buy a big chocolate bar. I could go in and hand over 100 pennies for a nice big block of chocolate, but it would take ages for me to count up all the pennies, and also it would take quite a while for the cashier to put them into his till. So to make life easy, it's exactly the same price. I can just hand over a pound coin. It's one coin, it's easy for me and it's easier for the cashier. And that's what we basically do in chemistry as well. It's our little currency. So we use moles instead of the number of particles. And to give you an idea about what that currency conversion actually is, it's this number here. So it's 6.022 times by 10 to the 23. This is how many particles are inside 1 mole. Now you're probably thinking, well, how much is a mole? Surely that's quite a lot. But I've actually got here 1 mole of water. So 18 centimetres cubed of water, not even a shot, actually makes up that many particles. And that's such a huge number, it's so difficult for us to quantify, but probably the easiest way I can think about it is it's basically like the same number of grains of sand that are in the Sahara Desert. So it's a huge number, and as chemists we can't be bothered to use huge numbers. We'd rather use easy numbers like 1 mole or half a mole or 10 moles. So much easier for us to use. So to give you an idea about how we can actually use this, here we've got our mole number. And what we can do with this number is we can times it by how many moles we've actually got. So to give you that idea, I've got 6.022 times by 10 to the 23. And if I wanted to half this number, well, in my head, I know it's 3.011 times by 10 to the 23. What I'm actually doing in my head is timesing it by the decimal of half, which is 0.5. And that's how you get your number. If you had a really bizarre, weird number of moles, that's fine. You can just times it by that, 0.16. I wouldn't be able to do that in my head, but putting it in a calculator, I'd be able to do it really well. So to give you an idea of an easy equation for you to remember, it's this. So AR is that number, the 6.02 times by 10 to the 23. The reason why we call it AR is it's actually called Avogadro's number, hence the big A. Then we've got N. This is the number of moles here. And that will give you the number of particles that you've got. Now this is actually a very common question that you may get in the exam, and what you may also have to do is do it the other way around. So if you did know the numbers of particles, you already know Avogadro's number, you can actually work out the numbers of moles by rearranging this equation. So this equation is really important, it's something that you should remember.